Okay, so I sent you several questions for you to practice for review for exam number 1. So here's the answer key, and I'm not going to go through and explain every question, but you may need to pause the video, rewind the video, whatever you need to do. Okay, but here are the answers to the selected problems that I sent you. Okay, so the first one is from section R7 in the book. Okay, so number 18, 26, and so on. Okay, so if you need to pause the video, go ahead. Okay, but I'm going to go to section R8 now. Okay, R8 was simplifying radicals. And if you look at like number 24, that's a good one to look at. When you take the square root of 9x to the 5th, the idea is you want to square root each piece. So square root the 9, that'll give you 3. And then when you square root x to the 5th, the idea there is when you look at a square root, well, how many x squareds will go into x to the 5th? 2 will go into x to the 5th with 1 left over. Okay, so you have x squared outside and then x to the 1st still inside the square root. Okay, so that's section R8. The next section, 1.4. Oops. Okay, I'll slide it up there in a minute. Okay, this was solving radical equations. And the basic idea there is, like in 26, you have the square root isolated, so you square each side. So basically what that does, the square root and the squared would cancel each other off to get just what's inside the square root there, 12 minus 2x. And when you square the right-hand side, x minus 2, you get x squared minus 4x plus 4. You go through and you solve that, and you should always check your solutions. You'll miss points if you don't reject an answer that doesn't work. So you go back to the original equation and substitute them in. Okay, so when you substitute in 4, that works. Negative 2 doesn't work. Okay, so you put a line through it or write reject next to negative 2, and x equals 4 will be your solution. Okay, and number 38, we have a 1/3 exponent. So to get rid of the 1/3 exponent, you cube each side or raise it to the 3rd. And that'll give you 2x plus 1 equals negative 1 to the 3rd. And then you solve that. And it turns out that negative 1 checks. And I'll slide this up to get 62 in there also. Okay, when you look at number 46, 50, and 62, those are what we call quadratic in form. There, what you look for is you noticed how x to the 4th, that exponent of 4, is twice as much as the 2. So that's quadratic in form. Over here, if you say 2x plus 5, okay, this is the U substitution. If you look through the book and and look at the videos online, you have squared here and then an exponent of 1 here. So that 2 is twice as much as the 1 here. So that is also quadratic in form. In 62, 1/2 is twice as much as 1/4. So that's also quadratic in form. And again, just like with other radical equations, you want to check these solutions to make sure they work. Okay, so I'll move on to section 2.5. Okay, 2.5 was the variation. Okay, so that's not a big topic on the exam. I'll just ask you a few basic ones. So you have to know that varies directly and varies inversely. Okay, so there's number 10 and 25. Okay, and then section 5.2. Okay, that's where we're looking at analyzing rational functions. Okay, 5.3, number 16. To find the domain, you set the denominator equal to 0. Well, there if x is 0 or -2, those are values that are restricted from the domain. So you say the set of all x such that x does not equal 0 or -2. Okay, now these I made little notes there. That's where the denominator is 0. To find a hole in the graph of the rational function, that is if a factor canceled. Notice there's no common factor here. So for example, there's not x plus 2 in the numerator and denominator for them to cancel out. Okay, so there is no hole in the graph. The vertical asymptote occurs when the denominator is 0 after you cancel any like factors. So x equals 0 and -2. Okay, those will be your two vertical intercepts. I'm sorry, two vertical asymptotes, not intercepts, asymptotes. The horizontal asymptote, there is none on this because the degree of the numerator is 3. The denominator, if you did x times x plus 2, the largest exponent there would be x squared. So 3 is larger than 2. So that's where you get the oblique asymptote, because the degree of the numerator is greater than the denominator. Okay, so there is no horizontal asymptote, but there is an oblique asymptote. I will not ask you to find the equation of the oblique asymptote. Okay, the x-intercept, well, that's when the numerator is 0. So you set x to the third plus 1 equal to 0. You solve that and get -1. Okay, so -1, 0 is the x-intercept. And then the y-intercept is when x equals 0. Well, when x equals 0, that was a problem. That was restricted from the domain. So your function was undefined there, so there is no y-intercept. Okay, and then other questions in 5.3. Okay, I'm not going to explain every single one of these. Okay, but this one, number 33, that does have a hole because when you factor the numerator, x minus 3's will reduce out. So we notice that -2 and +3, those are restricted from the domain. But when x equals 3, that's when you had the common factor. So what you do is after you reduce those out, you get x plus 4 over x plus 2. Okay, so x minus 3 factors reduce, so x equals 3 gives you the whole. Now when you plug 3 into your function, you get 7/5. So plug it into the function after you reduce. 3 plus 4 is 7, 3 plus 2 is 5, so 7/5. Okay, and you can read through the rest of those answers. Okay, section 5.4, these were the quadratic and rational inequalities. Okay, I won't go too crazy on these on the exam. Okay, but basically what you look for is where are your x-intercepts and where are there any asymptotes or holes, vertical asymptotes or holes. Okay, so the first one was a polynomial, so 0, 3, and -1 are x-intercepts, and then you make the sign chart. You substitute a number that's to the left of -1, put it into any inequality up here, and you end up getting a negative answer. Plug a number between 0 and -1, like -1/2 in, and you'd have like -1/2 times a negative is positive, and then -1/2 plus 1 is positive, so positive times positive is positive, so you get a positive answer between -1 and 0. And then put a number between 0 and 3, you end up with a negative answer. Plug in a number larger than 3, you get a positive. So for example, plug in 10, you'd have 10 times 7 times 11. Well, that'd be positive, 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 which is a positive answer. So then you write your solution. Where are we greater than 0 means positive. So between -1 and 0, and to the right of 3. Now notice there are parentheses, because the x-intercepts, where when you equaled 0, that's not a greater than or equal to 0, so it's parentheses rather than a bracket. Okay, and then 38 was a rational inequality. Again, you locate the x-intercept was at -5, because that's when the numerator is 0, and then plus or minus 2 were the vertical asymptotes. So you make your sign chart with all those in it, and then write your solution. Okay, and then chapter 6 was the compositions and inverses. Okay, so 6.1, the composition. was when you substitute one function into another. So when they define two functions, f of x and g of x, to find f of g of x, you basically want to put the x into the g function. So you go from right to left. When you do that, x into the g function gives you x squared plus 4. So now you want to put that into the f function. So f of x plus 4, I'm sorry, f of x squared plus 4. You plug x squared plus 4 wherever there's an x in the f function. So in place of x, you plop down or substitute x squared plus 4. So that's where this is coming from. And then plus the 1. And then simplify it to get x squared plus 5. Okay, so there's a few more problems with the composition. I'll move on to the next section, 6.2. Okay, 6.2 was showing inverses. Okay, inverses, the basic idea is you switch x and y in your equation. And if two functions are inverses, if f and g are inverses of each other, then f of g of x should give you x, and g of f of x should give you x. Okay, so you can show that two functions are inverses that way. Define an inverse function. So in number 54, we're given f of x is 1 minus 3x. So to find the inverse, you switch x and y. So instead of y equals 1 minus 3x, it's x equals 1 minus 3y. And then you solve for y. And then at the end, you replace y with f inverse of x. Okay, that's the notation, f inverse of x. Okay, and then you can locate the domain and range. Basically, the domain and range flip-flop. Okay, so the domain of f inverse is the range of the original, and the range of f inverse is the domain of the original. Okay, and then going on to 6.3, this is where we look at exponential functions. Okay, and then solving some exponential equations down here. Okay, the basic idea there is when you look at 3 to the negative x equals 81, you want to write them as the same base, because if the bases are equal, then the exponents must be equal. So once you get equal bases, you rewrite 81 as 3 to the 4th. That means that the exponent negative x must equal the exponent of 4. So negative x equals 4, and you solve that to get negative 4. Okay, and the next one, it started as 1/5. Well, 5 to the negative 1 is 1/5. And then over on this one, it was 125 to the 2x. Well, 125 is 5 to the 3rd. So then, when you have an exponent raised to an exponent, you multiply them. So the exponent x squared plus 8 should equal the exponent of 6x. And you solve those, make sure you check them and to make sure they work. Okay, and they both check. Okay, then the last thing on the exam is the start of logarithms. Okay, section 6.4 is the last thing on your exam. So rewriting exponentials as logarithms. Okay, logarithms are inverses of exponentials. So to rewrite an exponential, a to the 3rd equals 2.1. That is exponential. The logarithm, what you look at is exponent equals. Okay, so 3 equals. Okay, so exponent equals log, and then a little subscript with the base. Here the base was a, and then the answer 2.1. Okay, and you can go backwards also and say a to the 3rd equals 2.1. When your base was e, that uses natural log. Okay, ln. Okay, if there's a little base e down there that you know what to write. Okay, so that's section 6.4. On 40 and 41, those we're finding the domains for log functions. Well, when you take the log of a number, whatever you're taking the log of has to be greater than 0. So in number 40, x minus 1 had to be greater than 0. In 46, 1 over x minus 5 had to be greater than 0. So that goes back to the rational inequalities from the previous section. Okay, so that is the review for your exam. Now, I will not say that those are the only problems you should do to practice, but I just thought it would be good to send you some practice questions and the answers for them. What I suggest you do, I'm going to put the book in front here. when you look at sections in the book, okay, so for example, looking at section like 1.4, this was the radical equations and then the quadratic in form. I suggest you just go through and do some of the odd questions, okay, like number 19, number like 25. Okay, the odd answers are in the back of the book, okay, or online you should be able to click on the link to get to the answers to the book. And again, the odd answers will be in the back. I don't suggest you do every question, but that's a good way to review. Just do a handful of the odd numbers in each section. The other thing I suggest is, I'll just go back one page here. So look on page 116 in your book. Okay, you can see they do examples for you. Okay, so you don't need me to sit here making a video for you to do 15 different examples. Okay, when you look at an equation like this is quadratic in form. Okay, and they're doing the U substitution just like I did in the answer key. Okay, so going back and looking at the examples that the book does for you, okay, that is probably the best way to review. Okay, so here's another example of one like I did. Okay, that's quadratic in form. Okay, if you let u equal x plus 2, then you'd have u squared plus 11u minus 12 equals 0. Okay, and that's what they're getting at right here. Okay, so again, the best thing to do if you're stuck on something is to look at the examples that the book works through, and that should help you out a lot. It takes a lot of time, but that's the downside of an online class. All right, so good luck, and email me if you have any questions, and I'm more than happy to meet with you before the exam, but make sure that you don't procrastinate. Okay, make sure you work on the problems and get things done before the exam.